Alright, so here we go. Part 3! We're trying to do this. Okay, so how do we do this? Let's look at 31. Solve using the quadratic formula. So you want to be able to use this formula. I'm going to put it over here in this space. I'll erase it later, don't worry. Anyways, the formula is again negative b plus or minus b, whoopsie, square root of b squared minus 4 times a times c, all of that over to a. Okay, so control divide should allow you to do this. Obviously, you can see here this is simplified in radical form, so you technically would have to like maybe solve it, but before you can solve it, you have to make sure everything is on one side. Okay, so this is actually 6. My stylus is not working very well. Let's try that again. 6x squared minus 3x minus 5, because I moved the 3 and the 5 over to get those like that. And we usually move them over to the side of the x squared. We don't make the x squared negative, we make the other things negative. Okay, so that means my a is 6, my b is negative 3, and my c is negative 5. Now what I would do there is I would plug those numbers into the equation, so I would have here a negative of negative 3 plus or minus square root, notice that they're all plus and minus, b squared, which is negative 3, notice how I'm putting that in parentheses, squared, minus 4 times 6 times a negative 5, all of that over 2 times 6. Okay. 2 times 6 is 12, so it looks like it would be A. But then again, you can plug it in, type this in, you'll get a decimal answer. Just do the plus. Remember, you have to. This is one where we did the copy and paste thing, and then see which one would match up. And when they do, it actually ends up being A. The others don't match up, but what you could do is like see what decimal answer you get for this one right here, and then type this in the calculator. Again, control divide, 3 plus square root of 129 divided by 12, and then see that they match up. And that's the only one that's going to give you something like that. So there you go. So there's that one. I'm going to erase here, try to make some space, and go to number 32. Okay, so we'll see what we can get here, going, gone. Anyways, alright, so geometric sequence. What does a geometric sequence mean? It means that it has a common ratio. So they had to multiply or divide, however you want to think of it. They had to do something to where it would divide evenly. So, like if you say 216 divided by negative 36, negative 36 divided by positive 6, negative 6 divided by negative 1, you get an answer of negative 6. So there's your common ratio. So notice I was dividing by the number in front, like the last number divided by the one in front of it. Okay, basically, that's what it did. Write the recursive formula. Again, geometric, G sub n, the recursive formula was A1 times the common ratio. I know this was slightly, I know I had this slightly different, but this is what it basically comes down to. And raised to the n minus 1 power. Okay, so in this case, what I'm saying here is this. A1 is the first term. So negative 1 times common ratio negative 6 to the n minus 1 power. That would be your recursive formula. I'm not going to even ask you about the explicit. Don't worry about that. If it's on there, if that actually ends up being on there, I'll give you that answer because we did it differently, okay? Write the next 3 terms. Okay, so the next 3 terms here, let me figure that out because it actually came out to some funky numbers. So the next 3 numbers are negative 1,296, and then times another negative 6, 7,776, and then finally again times negative 6, and you get negative 46,656. Okay, and then they ask you what's the 20th term. Well, you would take this put a 20 here and type it in. And when you do that, so I'm saying -1 times a -6 raised to the 20 minus 1 power, and you get a really big number. Okay, I'm going to actually erase all, well actually I'll put it off over here. I got a number of 609,359,740,010,496. Okay, let's see here. So that would be 609,359,740,010,496. Big answer. But there you go. Okay, so there's number 32. 34 is actually very similar to that. Let me actually go over that one now, and then I'll go to the next page. I'd rather go over 34 since 34 and 32 are kind of similar. And tigers, if you don't like that, then too bad. This is what we're covering. By the way, my son named the cat Tigers, just so you know. Because, well, it's his cat, technically, because didn't really, well, cat just decided to adopt us. Anyways, moving on, arithmetic sequence. Okay, so you can see here, this one is being told is arithmetic, which means there's a common difference, which means they subtract to give you the same answer. 32, like if you subtract, again, remember, always work from right to left. 26 minus 29. 29 minus 32, 32 minus 35 gives you an answer of -3. The recursive formula is a sub n is equal to a1 plus the difference, the common difference, I'll put here common difference, times n minus 1 power. Okay, so if you plug that in here, you've got 35 plus -3 times n minus 1. Now you actually have to take a few steps on this one to solve it. So you got to distribute, and you have 35 minus 3n plus 3. -3 times n is -3n. -3 times -1 is +3. Combine your like terms. You get -3n plus 38. That is your recursive formula. Okay, so the next three terms of this would have been, I'll put it over here on my erase 32 now. The next three terms are 23, 20, and 17. Just continue subtracting. To find the 50th term, you can subtract a lot, or you could just put in 50 here or 50 here. Doesn't matter, you should get the same answer either way. So -3 times 50 plus 38 gives you -112. Put into the other formula, 35 plus -3 and n minus 1, you'll still get the same answer. So the 50th term is n minus 1, is -112. Number 35, I'll go to 35, then I'll go back to the next, on the next slide I'll look at this. First can has 1, so let's draw this out. Yes, we can draw it out, don't worry. So 1 can. Then the next row has 3 cans. 1, 2, 3. The next row has 5 cans. 3, 4, 5. Okay, and so on and so forth. The pattern continues. Notice here the equation asks what's the total. So look, row 1, there was 1 can. Row 2, there's 3, but now I have a total of, dang now, this is not letting me write. Now I have a total of 4 cans. 4 cans. Row 1, 1. Row 3, I have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 cans. And then if you keep that up, you'll see 4 would become 16. So the answer there is h squared, or x squared. So all you got to do is figure out which one matches it. And it's kind of like setting up, making your own table. All right, there is a formula here. Keep in mind, in exponential functions, this number should be positive, and you have to have it raised to the x power. This one is lowered by 20% every day. So when you have something like that, where are you starting off at? You're starting off at 100. So that should be your first number here. All of these have 100 first. Then, since it's going down by 20%, you have to change that to a decimal, 0.2, and you're saying 1 minus 0.2 because you're lowering. If you've been going up, you would have been saying plus. So the correct answer here is H. Discriminant. Discriminant again is b squared minus 4ac. If the number is greater than 0, it's 2 real. If it equals 0, it's 1 real. And if it's less than 0, in other words, a negative answer, it's no real solutions, or 2 unreal. You'll find out later on that means 2 imaginary. Anyways, got to make sure everything's over on one side, so you really have to look at this as 2x squared minus 4x plus 16. So you have to do that, and then you would do, if you do that and say negative 4x squared, make sure you put the negative in parentheses, so negative 4, close it, parentheses, squared, minus 4 times 2 times 16 gives you an answer of negative 112. So since that answer is negative 112, and all I care about is actually negative, the correct answer here is that there are no real solutions. The discriminant is negative 112 and that there are no real solutions. Okay, I'm going to erase here so I can make some more space. Hopefully you pause, but you can always rewind me because I don't mind. It won't hurt my feelings. It hurts my feelings so much. Okay, so what do I do here? Simplify the radical. So, well, let's see. That's the even number, so it's divisible by 2. So 792 divided by 2 gives me 396. That's divisible by 2, so I divide again. Divide by 2, and I get 198. It's still even, so I would divide by 2 again to get 99. Now it's not even. So what can I divide by? Well, I divide by 3 because that's an odd number and it gives me 33. Divide by 3 again and I get 11, and 11 is prime. So now I've got nothing but prime numbers. Just these numbers right here. Okay, take your pairs, pair of 3s, pair of 2s. So I have a pair of 2s, pair of 3s that go on the outside. Left over, I have a 2 and 11 on the inside. So 2 times 3 is 6. 2 times 11 is 22, and there's my answer. So remember, you can start dividing. Remember, odd number, you just know your division rules. Start dividing. Pairs go outside, leftovers go inside. Okay? And that's pretty much it. There you go. If there are any questions, feel free to let me know. Hopefully y'all will do well. Thank you so much. It's been an interesting year, to say the least. But I would like to say this, for those of you that have been hardworking, doing your best, or trying to do something close to your best, and really being kind of like trying to be good students, it has been a pleasure working with y'all. Y'all know who you are. Thank you so much. Usually those of you watching these type of videos are usually the hardworking ones anyway. Good luck, and if you ever need any extra help next year, feel free to stop by my room, wherever I might be. I don't know if I'll be in the same room. Anyways, thank you very much, and take care.